Hi, dear students. A warm welcome to the Astro Week hosted by Astronomy INC under the Astrobiology and Paleontology Certificate programs. Today marks the day 8 of this exciting series for the South Asian region. And what we are going to talking about today, it's a very unique and special topic, human analog space missions with a CHASM. So as we venture into this critical topic, we are honored to introduce a distinguished guest speaker from our special team, Dr. Eleonore Poli. And she earned her PhD, Materials Science and Metallurgy at the University of Cambridge, and now work as a postdoctoral researcher at the CHASM, focused on additive manufacturing. Her work includes developing 3D printed metal structured for projects with the European Space Agency, such as shock absorber for the lunar landers. With a strong background in mechanical engineering, she has experience in both academia and industrial, including at Pilatus Aircraft. A passionate space explorer, Eleanor served as an analog astronaut led at the Asclepios I mission. I crew an 8-day moon simulations in lunar-like chaos. She co-founded CHASM, a global network for analog space missions, and the TEDx speaker and ion triathlete. As a long-term member of the Swiss Space Museum, she blended science, storytelling, and space history into the inspiring audience of all the ages, just like today. At the Fantasy Bazaar, a Swiss Comic Con, Eleonore Poli will explore how 3D printing is transforming space explorations from the rocket engines to the satellite parts. This a powerful technology is revolutionized how we design for that space, making it possible even for the garage-based innovations to take a part into the next space age. So Dr. Eleanor Poli is a active research member of the Astronomy INC since 2021. So with that being said, I would like to invite this talented and the glorious scientist, Dr. Eleanor Poli, to address Astronomy INC International platform. Dr. Eleanor, now it's your time. You can get started.
Thank you so much, Aravinda. It's a pleasure to be here today. I hope that you're all having a great summer so far, not too warm, not too cold, plenty of time to apparently watch videos about space. I said today I'll be talking about analog space mission, and it's true, I'm an additive manufacturing postdoc. I've worked as a materials scientist for several years, earning my PhD about 2 years ago. I'll be talking about CHASM, and I'm going to take the opportunity of having the logo right now quite in a large stretch and zoomed in to make you look at this logo. This logo, as you can see, I have an astronaut. An astronaut is looking at the Earth and looking at Mars, and in between you have a chasm, basically a ditch, a separation between the two. This logo was basically initially the logo of Mars Society UK, which had just one planet in white. And when I created CHASM, it originally was the conference on analog space missions. We were looking at how to make a logo, and we actually started working with Mars Society UK. And we thought, why don't we, since we are working together with Mars Society UK, why don't we just reuse this logo? And we show the difference between Earth and Mars. When you do an analog space mission, you're trying to simulate Earth on Earth, Mars or Moon mission. So you want to have those conditions. And basically, those simulations show some of the discrepancies between the two. So you're looking at both of them and you're looking at the chasm in between. And it's quite fortunate that it rhymes with the community of human analog space missions. So yeah, as said, I am a materials scientist, I'm an engineer, I'm from Switzerland. I did my bachelor's in Switzerland, then I moved to the UK, in Cambridge to do my master's and then my PhD in materials science and engineering. The reason behind is that I enjoyed studying materials science. I thought it was a kind of science that allows us to study many aspects of life, many aspects of science. It can be anything from how chocolates are made. We literally have materials science classes on chocolate because that's how important it is in my country. But we also do sports, and we do aerospace application and sustainability applications. So anything from batteries to rocket engines are made from materials. And I'm not someone who enjoys choosing. I like having many options. I like being able to do many things. So material science was, for me, quite the choice. And then I'm, so I said, the CHASM founder and director, and I'll be talking way more about this soon. And I'm an analog astronaut. What you're probably thinking is, what's an analog astronaut? What's an analog mission in general? So to tell you a bit more about how I got started in all of this, and maybe if you're young students or just students, you might be thinking this might happen to you too. And this might hopefully inspire you. I was on, I can't remember which social media. I don't know if I was on LinkedIn or Facebook, and I was following basically one of the pages of something that we call the Swiss Space Center, which was a research center at EPFR, one of the main polytechnical universities from Switzerland. And I obviously was always looking at the opportunities, and I see this ad. I see this ad saying, do you want to become an astronaut? Now, what you have to understand is that in NASA, they recruit astronauts almost every year or every 2 years. You can't just send your CV every year and hopefully you get an answer. But for us in Europe, Switzerland is part of the European Space Agency, is one of the member states. We've got about 24 countries, I think, member state in ESA, maybe 23, I'm not 100% sure, but we've got lots of countries that are member states. And therefore you can apply to it when you're part of these member states. But the European Space Agency only recruits every 10 to 15 years. It might increase in the next year, but for the moment, it's really every 2 generations, let's call it. And that's tough. That's really tough, because it means that you could potentially be the best candidate and you're not sure that you would get to space because you might be too young at some point and then you might be too old. That's actually what happened to me 2021. That was the latest recruitment we had, and I was 25. I was too young. I didn't have the 3 years of experience after my PhD. And that felt sad, but I'm hoping that they're going to recruit again, and this time I'll be the right age and the right CV. But anyway, let's come back to this. So imagine you're in my shoes. You really want to be an astronaut. You know that the European Space Agency is not recruiting right now and hasn't been for the last 10 years. And you see this. And you're thinking, well, let's go for it. So I was the first one to send my CV. I was the first one to send my motivation letter. Literally, I think they posted this. I saw it. 20 minutes later, they had my they had my folder. They had my application. And I went through the recruitment process, and I became crew commander. So let's talk a bit about what it takes to be an analog astronaut. Because what turned out to be this ad was not to be a real astronaut, but it was to be an analog astronaut. What we wanted to do, what this mission wanted to do, was to take 6 students and to place them in an underground, I think I have a picture right here that you can see a bit of the walls there. I'll go back to the other one. What they wanted to do is put us for 9 days underground, 450 meters below the surface of the Earth, and to simulate being on a base on the moon. Why? Well, for one thing, those 3 students who created it, they were insanely smart. They were motivated. Maybe they were a bit too bold. Maybe the studies were too difficult and they decided to add even more difficulty to it. But in any case, they created their own space mission simulation, and they made us do recruitment. The recruitment was actually quite similar to what you have as an astronaut for the European Space Agency. So you have to send your CV, your motivation letter. Then you have to do an English and psychological test. Then you have to do a cognitive test and a group test and an interview with a psychiatrist. And you even have an interview with astronaut Claude Nicollet, which was our only Swiss astronaut at the time. So that was quite an honor to be able to be evaluated by an astronaut. And Claude Nicollet is not only an astronaut, he's one of those wonderful human beings who just love space so much and wants to spread it to all of us. And well, the first time I met the others of the crew was during the last interview, because we all had a group test, we had to work together, and we had to also tell people, oh, I would like to work with this person, but not too much with this person, so that they already would see if there were any crew preferences and dynamics. And then the second time I saw the crew was that time. So as you can see, there's some snow on the floor. This was what we call an extreme environment training. It's part of the training that we had to do for analog space missions. The goal was to become a team. When you have to work with others in extreme conditions, when your life is on the line, when you're uncomfortable, this is where some parts of you will come out. Maybe you see that under pressure, you're very good. And maybe you see that you really, really grumpy, and you don't like the hot, and you don't like the cold, and you're hungry. Like, we're all very different, and that's fine to be different. But in those conditions where you're going to be uncomfortable, where you're not going to be able to take a shower for 9 days because you are on Moon or Mars and there's not that much, you don't have a shower, whatever it is, you need to understand how you will react psychologically and physically. And basically, those extreme environments are there to push our limits, to work as a team, to learn how we operate. And what I learned the most about those trainings were we basically had to spend the night in the tents by -10 degrees and snowstorm. We went to do diving. This was my first time diving. I had never done diving in my life. I always wanted to, but never had the chance. And we went diving in under the ice. So I didn't even get a theoretical class because I was with professionals. I was with 2 professionals. One is an explorer, and I've been doing ice diving for 25 years. And they just told me, you take the breather here, you just don't fill up your lungs, you're going to be fine. And they were holding me. And we just went under the ice for about 15 minutes. After 15 minutes, basically you start really freezing, like you can't feel your fingers and anything. So they pull you out. But basically, I realized that, because I was a bit stressed, like the first minute I was on the water, I was like thinking about all those diving accidents that I heard about, and thinking, oh my God, maybe I'm going to breathe in too much and my lungs are going to explode. My face was freezing here. You just don't know. And then after 1 minute, I was like, wow, this is so relaxing. It's like I'm floating in space. And so we went diving that afternoon in the ice, and then the same evening we went again at night. And what we did is we went below the ice, and already just seeing the bubbles form below the ice is fantastic. It's not something that you get with normal diving, because normally you don't have a sheet of snow or ice on top of you. But there you had. And it was the images that you get are completely different than the one you might get when you go diving in the sea, etc. And you have fishes and stuff like that. But there that night, we were below the ice, and we're just floating in the cold and the silence. And we turned off the lights. So it meant that you're just floating in the obscurity. It's just completely dark. And you have the feeling really that you're in space. And that was one of the most relaxing feelings I've ever had in my life. And I was thinking, wow, if I ever have to do an EVA, I hope it's like this, that it feels like that. But yeah, so we did 4 days of that training. We did psychological training. We did team training. We did public speaking training, because our mission was sponsored. So we needed basically to talk to media for it to be worthwhile for the sponsors. We had, communication training with our radios, etc. And we had lots of experiments to take with us. This was the base, and we also had to do sports a bit like astronauts. So you can see that it's a granite base. It was about 2 kilometers below the surface. So you had to take a tunnel for 2 kilometers before you got to the base. The locations was Grimsel Pass in Switzerland, and you had 3 lakes basically, and those lakes were connected to some dams, and the hydropower station was like about 1 kilometer away from our base, which meant that if there was any problem, our location could get flooded. So we had an emergency tunnel we could take in case. So we had to be a bit careful about this, like to just be trained for the procedures. The location is also where they do nuclear waste storage tests. Now, it's not as funky as it sounds. It doesn't mean that we suddenly sprouted 6 fingers or something like that. But what happened is simply that they would test storage of materials in very, very large stones. It's a fantastic place, actually. Most of the measurements, they do take 50 to 60 years to be done. So it's research on the long term. They also look at seismic activity, etc. It was a fantastic place, and we made it our base, basically. It was really our home. This is one of the other parts of the tunnel. This was where we had a mission control center where we would talk with the other astronauts that were back on Earth, basically. So 2 of them had trained with us, and they were staying in the mission control center, and the rest of us, we were in the base for 9 days. The only time we'd go out was for the EVA. Now, this doesn't look too much like the moon Mars, and that's true. The reason for that is that initially our mission was supposed to be in April 2020, and COVID happened, as it did to all of us, and we had to switch the mission to 2021 in July. And yeah, even our spacesuits, they were actually made for February temperatures, which in Switzerland is between -10 to 8 degrees max. There was like 28 degrees. So when we came back, we were smelling and sweaty, and because we hadn't been able to take a shower in 8 days, and that was not fun. And then you can see there was the COVID era. This is when we were waiting for the journalists to arrive. And that's actually quite good. I was wearing a mask there because I think maybe it was my first time talking to journalists. And we went into the tunnel. We were waiting in front of the airlock, and we were waiting for the crew to come. And the bus stops in front of us, and you hear the bus coming for quite a while. Imagine this really long stone tunnel, and you can hear basically the journalists coming and the bus coming, and then they get out and they have all their cameras and they point it at you. And I was like, I'm glad I have my mask, because right now I'm like, ah, and I was just, luckily it was hiding my facial expression of like the stress I felt. And yeah, I said we wanted to have the journalists have a look at our mission, because it was a student mission and nobody knew about those analog missions. Probably you've never heard about analog space missions, and we're really happy to have people there to film this and to share what we were going to do for 9 days. So to bounce out on this, analog missions are not really well known to the public. Most people have never ever heard of the word. While our mission was being postponed, so in May 2020, I had to put my PhD on hold, in the sense I had to go back to Switzerland. I had to take care of my dad, and my department had closed, so I couldn't work on my PhD. So I did, the only thing that made sense to me was to attend every online webinar about space, and I learned about analog missions. I learned about different organizations than Asclepios, which was my first mission. I realized there was one in the US, there was one in Spain, there was one in Austria, yada yada yada. And what I was very surprised about is that we were very different each, but we faced the same problems. The lack of communication, the lack of awareness, the lack of funding. It takes a lot of money to create something like this. Imagine you want to go and do a summer camp somewhere, and you need food for 20 kids for at least 5 days, and then you have to find a place to sleep, and then you have to find the right clothes, and then you have to train them, and then you have to find people who work with training, and then you need to find people who take care of them at night, and then you need to find experiments so that they have something to do, activities. Now imagine that it's not a summer camp, it's a space mission simulation, which means that you want protocols, you want people to be working hard, you want real experiment, not just jumping in a pool for the whole afternoon and maybe skateboarding. You actually want something that's quite big. So you can imagine how much money goes in this. And for example, Asclepios I, the budget was about 250,000 francs. It's huge, and the students managed to find this money. Like, it was about 80 of us that were working on that project, and we got funding through sponsors. So $250,000 is obviously not cash. It was partly cash, but a lot of it was sponsoring clothes or maybe cameras or computers or things like this, basically. But all analogues suffer from this lack of funding because analog space missions are not well known. Some of them are managed by the European Space Agency or NASA or JAXA or the Chinese Space Agency. These ones, they're okay. But a lot of people, like Asclepios, had decided to create their own space mission, and they lacked funding for lack of understanding and visibility. Another problem of those analogues is that you will see probably some pictures of people who've got a motorbike helmet on the head, like we had for our first mission. They take a selfie and then they think, oh, I've done a space mission. And it's not completely that. Some missions are extremely good in terms of fidelity, in terms of feeling like you're in isolation, feeling like you're in space, doing actual science, having a protocols of feeling like an astronaut, you know, like for us, we would wake up at 6:30 in the morning, we would have tasks, we would have a planning for all of day. Each of us had different tasks, and it could be making breakfast or whatever. We had to do our psychological questionnaire first thing in the morning, cooking, cleaning, and then briefing with Mission Control Center about the day and experiments. Then some of us will do that experiment, others will do this one, others will do the training, sports training to maintain your muscle mass as you would do in space. And the whole day was like that. Every item that we used, we had a number, and actually I have a fun story about that I'll tell you after. But some missions, people have their phones on them. People can go on Instagram while being there. And when you're an astronaut on the International Space Station, you do have some moments for you. You do have moments where you can call your family, but certainly not whenever, however, whatever, right? It doesn't work like that. And there's also lots of experiments conducted. So I would estimate to about at least 200 experiments, 200 even potentially papers a year that are published, produced by analog missions, because there's over like 25, 30 habitats in the world, and they're not standardized. If any of you has worked in a laboratory, you know that you have to work at given temperatures, you know, if you're working in the open air. So you're going to have a standardized humidity, controlled temperature, controlled pressure, to make sure that when you do a measurement in Sri Lanka or in Vietnam or in Australia or in the US, it's going to be the same as I would do in Switzerland, for example. Okay? But the problem is those habitats can be everywhere in the world. We have habitats in the Arctic. We have habitats underground in Spain, in caves. We have habitats in Poland in old military bases. Each of them has a different humidity. Each of them has different temperatures. So the problem is, how can I use the data points and the experiment results conducted in such environments when there hasn't been a standardized developed, or when there's no control? So then you look at all of this, and my idea was to create CHASM. Originally, what I wanted to do is I wanted to bring people who love analog space mission, who participate in these, and get them together so we could communicate, we could talk, and we could exchange and find solutions. Originally, it was the conference on human analog space mission. This was the first edition in Cambridge, because at the time I was doing my PhD there. So I thought, you know, people think Cambridge is like Harry Potter. Hopefully, if I do the conference there, people will attend. And I was really lucky. We also had about 6 participants online. So we had more than 12 missions represented, despite the fact that in there, I think in this group, only one guy knew me. All the rest, they didn't know me, right? Because I just hadn't met them before, right? I didn't know Leszek from Poland. I didn't know Patrick from Marseille, UK. I didn't know Manuel from Astroland in Spain. I was just this idiot who one day sent them an email and said, look, I want to create a conference on this. I want us to exchange, and please come. And they did. And it was amazing because we got to exchange. But the most amazing part was that we realized when you do an analog mission, when you decide to spend your free time, your holidays, your sweats, and your blood in these things, you are surrounded by people who are like you. You find people who are ready to spend their free time to make science go forward and to understand if they want to be astronauts. And when you want to be an astronaut yourself, you might feel a bit lonely. There's not that many people who are ready to make the sacrifices that are required to get there. And this basically created a community of like-minded people. So after that event, basically, it went really, really well. I was extremely happy. It was my first time organizing an event like this. Basically, we decided to do workshops. So this is, by the way, was the original committee. First it was me alone, then it was these guys, and then now it's part of the committee. I think this picture we took it, last year. So you can see lots of smiling faces. We have Terry, he's in the US. Elias, he's a Syrian and Swiss. Axel, he's one of our astronauts. He's French. Sam, he's British. Olivia, she's British, but she was in the US. Lucy Rachkova, she was in Czechia. Thomas, he's Slovak, and he's our other astronaut wheelchair user. Ginevra, she's 16 and she works incredibly well, and she's in Italy. And we have Martin, he's Czech. And we have also Alan, he's here actually, he's like 74 now, and he's been working with us. So Ginevra is our youngest, Alan is our oldest, and both of them are working incredibly well. And it's been so far amazing working with them. And they've helped me do amazing stuff, which was, for example, the workshops. So what we did in the first workshop is basically we want to visit different habitats. So the first one we did at Lunaris, and what we did is we took different topics. We used the mirror boards to basically write things down. So for example, we say we have those experiments, we have issues with them. How do we solve them? So we created those workshops, and we went to different places. So this was our first one at Lunaris. As you can see, this is an old aircraft military bunker. And it's actually one of the only habitats that is wheelchair accessible. Lunaris was really a pioneer in the sense that in 2017, they had the first analog mission where they had somebody with a disability. So the man was blind and he was missing a hand and some fingers. And basically he managed to do a 2-week mission there with the crew. Then the second one was in Astroland, and you can see about the cave. So this is one of the cool pictures and the spacesuits that they had. And this is an underground cave. It's 1.6 kilometers long as an underground lake. And Arvinda, I think you would love being there because they actually have done lots of geology and biology studies. And those caves in Spain, they used to be submerged by the ocean. And a lot of those caves have not been really explored. And what they have found is some amoebs and some sort of algae and bacteria that you do not find apparently anywhere else on Earth. So sometimes by simulating the moon and Mars, we really create the same conditions, aka finding some new life, some new species that we didn't know about, while being still in isolation. And then one of the last one we had was, you can't see too much, sadly, the picture crops a bit, but we had the Hydronaut. The Hydronaut is an underwater habitat. It's about the size of the Orion capsule, and you can put 3 people on there, and it's in the Czech Republic. It was, at that time, you had removed it from the water, so we could go and visit it, but normally it's in a lake underwater. You can see maybe a little bit here, the design, and Miho, who's one of the medical chiefs in charge of it. And this time, the workshop, what we focused on was hyperbaric medicine and just space medicine in general. We were really lucky to have some psychologists and some medical doctors and flight surgeons who've been working in that. And it was really, it was a really amazing opportunity to join actually the Space Czech Week and do that. So we've done some other workshops, but I'm not going to list all of them there, but just to give you an idea of the concept behind it. Then one beautiful event was the weekly release party that we did at the BIS, the British Interplanetary Society. So they were there, our first conference, and we got on super well. So we thought, you know what, we're going to go there and do an event there so we get to visit and at the same time, share what we do. And the wiki release party is basically we created a wiki database of all analog missions. And so if you go on our wiki, you will have really, it looks like a Wikipedia, but it's only analog missions. And this way, if you want to do a space mission, you can have a look at it and you're like, oh, this one is 2 weeks long, this one is 1 week long, this one worked on Mars, etc. And then you can try and find what kind of research has been established there. So we were really, really lucky to get to work there. Every time we see a new analog mission, we try to put them in there so that people can understand more about analog missions and be updated. But sometimes, like, analog missions are so widespread now that sometimes one pops up and we had no idea it existed. And here you can see a bit how it looks like. So for example, this is the Mars 500 mission. For those of you who don't know, the Mars 500 mission is one of the colossal missions that was conducted. Mars 500 basically simulated the mission 2007 and 2011, and it was based in Russia, but it was actually a cooperation. They had the European Space Agency, they had Canada, they had China, etc. And they wanted to simulate a mission to Mars. Obviously, you and I, for example, we don't really have the time to, do a simulation for a year or two, or you have to take a year off from your work to go and do that. So these people, they took 520 days and actually a bit more because you have to do tests before and quarantine before, etc. And they went and did this long mission compared to the 2-week missions that we usually have, or 1-month mission that you can find. And they really simulated going to Mars in the sense that they had their base and they were the spaceship, let's call it, with their sleeping quarters and their kitchen and their library and whatever. And then once they arrived on Mars after a couple of months, a bit more, they had an EVA pit. EVA stands for extravehicular activity, and it's basically this space where they had lots of dust and earth and whatever, and there the atmosphere was toxic. The CO2 levels were much higher, the same way you would have on Mars. So they have to wear some spacesuits. Obviously, they're not as heavy as the spacesuits that we have on the Moon and Mars because you don't have all the systems, but basically they needed something to breathe correctly. And they worked on in the EVA pit, and then they came back after a 2-3 hour EVA, etc. They would simulate really doing geology, yada yada. After being on Mars for a couple months, they simulated the journey back. This is a very, very important mission. The reason I say this is because so far the longest space mission, real space mission, was 417 days. So we have no one who's lived for longer than 417 days in microgravity conditions, and no one who's been more than 2 weeks on the Moon, for example. From what we learned from this person that was in space for 417 days is that physiologically it was really absolutely damaging. Now we are improving systems to maintain bone density and maintain the body functions that are improving all the time, and it's getting much better, but it's still a bit worrying for Mars. But this study showed another problem, which was psychology, the isolation. There's not a problem when you go to Mars. Mars is really far away, as you know. I mean, saying the evidence, but one of the problems with Mars being so far away is communication. When I call an astronaut on the International Space Station, there's not really any delay. When you call an astronaut on the Moon, there's a couple seconds delay. And when you call an astronaut on Mars, depending on the position of Mars relative to the Earth, it's going to take 4 minutes to 20 minutes one way for your message. And that means that if I have a problem, it's not going to be Houston, I have a problem, and then 2 minutes later someone's going to just say, oh, of course, what can I do for you? It's not going to happen. It's going to be, Houston, I have a problem, and for 4 minutes I have big problems, and then they hear that and say, okay, go ahead. And now it's been 8 minutes before any sort of thing. And that means that your crew is going to have to be way more independent, and your crew is going to be way more isolated. From a psychological standpoint, it's incredibly important to learn about this, to understand this, to how are we going to deal with that? If we ever go to Mars, how are we going to deal with this? Romain Charles, he's one of the astronauts. He's here, I think. He came to talk to our other conference last year with CHASM, and he told us that one thing that really helped is that his little sister had prepared care packages every month. So every month he'd be looking forward to, I think it was a postcard and some notes and maybe some chocolates, something like that. But basically, she had prepared something that he had with him to look forward to. And sometimes that's all that you need in a sense, but we're going to most likely need way more than that. They also were talking about the different cultural differences. Obviously, this is something that we have a lot in analog mission. It's one of the richest points of doing analog missions is that you are confronted to people and their whole. Imagine right now you're spending 520 days with 5 other people in a tin can. And they're from different countries, they're literally from different continents. And maybe they have a different way to, cleaning the toilet. Or maybe they have a different way of brushing their teeth. Maybe they have a different way of eating. Typically, you've probably been next to someone who eats with their mouth open or makes noises when they eat. And then somebody who sings really loudly, someone who's always late, someone who's always on time. Now, it's okay when you're on Earth and you can just go and complain about that person to somebody else if it annoys you. But when you're in something like that, you can't escape them. They are your friends, they are your colleagues, they are the people responsible for your life. They are your boss, or they are your employees, depending if you're the commander or not. And they're your roommates, and also they are the closest humans to you during that time. This is why analog missions are incredibly interesting, is that we can really simulate quite well the isolation and dependency that is required in spaceflight, and what we can do with that. Anyway, so this was a little sidebar about the CHASM Wiki, and you can learn more about other analog missions in that. Then the other topic I wanted to discuss about, it's one of the branches that we created about 2 years ago with CHASM. We created PowerCHASM, which is a spacesuit consortium, and what we want to enable coordination between researchers on the topic of parastronauts. So parastronauts, they are astronauts with a disability, which means that, for example, you're missing a leg, or you're in a wheelchair, or you're missing a hand. This is somebody who has an handicap, either born with it or developed it. If you look in 2021, the European Space Agency, for the first time ever, had a recruitment for the parastronauts with a lower limb mobility issue. So, for example, we have the first paraastronaut ever. He's John McFall, and he's missing his right leg, if I remember correctly, below the knee. So he had an amputation. And he's now one of the first astronauts, and they have to do all the qualification, etc. So what we're trying to do with PowerCHASM is to use analog space missions to basically map out what are some modifications we need to bring to habitats and to different locations to improve space missions for parastronauts. For example, if you have a parastronaut that is blind or deaf, you need to change protocols. Right now, Lunaris is preparing a mission with a deaf astronauts, so they have to think, okay, how are we going to deal with emergencies and alarms, etc.? What kind of radios are we going to work? Typically, yesterday we were having this chat with one of the leads, and she was saying that the one thing she's worried about is when they go on EVA, because when you go on EVA, your visibility is not great already, but also there's the fan, so normally we don't hear very well, and you don't have a lot of dexterity. Now you have someone that can't hear, and maybe something happens to them, and maybe they want to communicate with you, but maybe like they can't hear if you hear them, or maybe they don't have the right communication tools. So we have to think to communicate with them. You kind of have different signals, but again, you're wearing gloves like in a spacesuit, so you don't have the right mobility. So it's complicated. Or maybe you need to have a visual alarm and visual way of sending information. So typically what I suggested is that you have a smartphone on your forearm, and basically that any communication would go through the smartphone via a specific app, for example. Another thing that we did is CHASM card. We tried to create what we call a comprehensive analog research database. So as I mentioned, analog space missions produce an enormous amount of science, enormous amount of data. And what we're trying to do is make sure that people actually look at the topics before they do a research, so they don't do something that's redundant, and can contact each other. So it's a way to align each other. It's difficult to do this because you have to find everything. We put them in Excel file and then we feed it to a database, but we're still working on it, and it's going to serve a wonderful purpose. Between all these tasks with CHASM, obviously I'm the director of CHASM, I'm the founder, and I cannot be working on analog missions without partaking in some of them. So the last year I did 2 missions, so I prepared 2 missions. So basically, after being commander for Asclepios I, I couldn't do a mission. I was supposed to be commander for Pilatus I, but actually was clashing with my PhD, so didn't manage to do it. And then I joined the GHOST team. The GHOST team is the ground operations support team from the Austrian Space Forum. The ground operations support team is basically in charge of the safety, the experiments, and the logistics. We have astronauts here. You can see that they have 50 kilo spacesuits. They have a fan in there, they have a battery, they have the antennas with electrocardiograms data, temperature data, CO2 values within the suits. The thing is, because the suits are very heavy and they have an exoskeleton that hinders movement, if one of them were to fall on their back, they can't get back up. If the battery catches on fire, which can happen, they cannot remove it themselves and they can burn to death. It's not a fun situation. So we are not on Mars. We are volunteers. We work very hard to make it look real, but we're not going to let anyone die because of a mission. So what we did is we had us, the team, so we had the astronauts, they were in the habitat most of the time, and us would be basically following the astronauts around when they were outside with the spacesuits. So we're trying to be real ghosts, like woo, hiding. What we try to do is to be as discreet as possible while being near them. If anything happens to them, we can do a check. We have our medical doctors to check on them and make sure it's fine. And here you can see the procedure of when we have to potentially remove the helmets if it happens outside during a simulation. And you can see there was a very big crew. What was absolutely fantastic is that I had to be Ghost Commander. I had to step in for one of my colleagues that was called on the front during the Israel-Gaza conflict. So it was interesting to see how politics affect us too, and we can see how they affect NASA right now. So I had to step in as Ghost Commander and deal with that beautiful team over there. And it was really fantastic. I had to learn a lot about Armenian culture, which I didn't know about. I was working with Austrians a lot, which I hadn't before. And it was sometimes interesting, let's call it, but absolutely lovely and really fantastic people. So that was a mission that we took part in place in March, April last year. And then I was also the head of astronauts for Chilice, which is a mission where we wanted to simulate 2 weeks lunar mission in a lava tube. So for those of you who don't know, a lava tube is basically lava that came from a volcano, obviously, and then they created an air pocket, and this air pocket basically helped the lava dry, and it basically made a huge hole. So once it's gone, once the lava has solidified, you are just left with this hollow structure. And the reason we want to go in there, the reason why we want to do simulation in those locations, because they are natural shelters for the radiation. The moon, Mars, they don't have a magnetic field like the Earth has, so we're not protected from solar particles the same way that we are on Earth, okay? It means that we're really subject to radiation. In addition, Mars and the moon have almost no atmosphere, like very, very limited atmospheres. This is another thing that doesn't protect us. So what you need to do is you need to build habitats that have much better shielding, or you need to use existing habitats or structures and then build your habitat in that. In this, for example, you do by using lava tubes. They have natural lava tubes on the moon and Mars, natural locations where we could try and live until we build bigger habitats. And what Chill Ice does, what Icy Space does, is basically have an inflatable habitat. You put the astronauts with the spacesuit, you give them an 8 or 9 hour autonomy, like say you got 8 hours of oxygen and then nada. And you got this time only to go to the lava tube, install the habitat, and then spend a week, 2 weeks, 3 weeks there. And I was in charge of the recruitment for these astronauts, and it was really interesting because I'm trying to do all those different kinds of roles in analogues to be an expert at it. I cannot claim to be a director of an analog mission organization if I am myself not in it. And I had a fantastic time. This was our final crew, 4 fantastic people. And the recruitment was quite similar to the one that we did for Asclepios, but I wanted to create some differences with one of the, I say, recruitment phase. I had lots of pleasure doing it. So from a psychological standpoint, it was really amazing. What we did is that I taught 4 people. We wanted to do a group test and look at group dynamics and basically are people team players? Are they on time? Are they organized? And you take 4 candidates that have already passed the first 2 steps, and you tell them, okay, you are 4 people. You have 10 minutes to introduce yourself, which means 2.5 minutes. And you say who you are, what you do, what you like, why you there, and a fun fact. So what was really funny is some people say, my fun fact is that I do skiing. And I was like, I'm not sure if you're not very funny or or if maybe you think in contrast, but it's already funny to see differences like that. You see people who think that 5 minutes is 2.5 minutes, so don't have time management, but that's fine. So in 10 minutes, you are able to know that the other person seems confident and what kind of job they have or what kind of studies they have. And in the next 10 minutes, I asked them, now that you've talked, I want each of you to give the title to the other. So what I mean is like we're gonna have 4 positions. This is quite standard in analog mission, is that you will always have a commander. So it's the person that normally they don't need to do too much if everything goes smoothly, which is never the case. But basically they are there in case you need to take charge. In case there's an emergency, you don't want 5 people making decisions. You want 1 person taking decision and guiding the team. Okay? And that is one of the only jobs within this, one of the roles, which is a soft skill. It's not a hard skill. It's not something where I can say, oh, I've been to the Academy of Commanders. No. Some people are born commanders, some people can learn partially how to be, but it's something that you can have 20 PhDs and not be a commander. So it's something that is difficult to evaluate without knowing the person. And it's also, I don't think it's not necessarily positive to be a commander or not, it's just a trait of character, but people think that it is something very positive. So if they're trying to impress, they will try to get that position without necessarily being the right fit for it. So it's very interesting to see what are going to be the candidate's reaction to this task. Because if you, for example, a crew medical officer, easy, she's a medical doctor, right away you're like, okay, you're going to be a medical doctor. Then if you have a scientist, you think, okay, you're a scientist, payload officer, because you take care of the science. And then if you say, I'm an engineer, okay, you're chief engineer. But maybe the 4th person is going to be all 3 of these things or 1 of these things. So maybe you have 2 medics, or maybe you have 2 pilot officers. So this is where you have to do a call of character, judgment of character. Okay, so you've been through the first 20 minutes in the sense that you have shown what kind of astronaut you are, what kind of person you are, you have your role, and then I give you half an hour to basically show me how you work in a team. So I deactivate my camera and I give them an exercise. And this exercise is very much used by NASA, by ESA, by lots of recruitment platforms. And it's an exercise where you've crashed with your plane, you have a list of 30 objects, and you only have time to take 10 or 20 of them before the plane just explodes. And usually it means that you lost in the mountains or on the sea or somewhere where it's really remote. And what you're going to try to do is survive. So usually you have food, you have knives, you have, I don't know, matches and stuff like this. And you try to solve this. And first you're going to make your own list. You're going to think, well, I would do this, 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 this. You have 5 minutes to decide. And then the rest of the exercise is done with the team. So they have to communicate. And I'm turning my camera and I'm just watching them at work. And it's very interesting because you can see who is interrupting the other, who's wary of the time, who's like keeping in check, okay, it's been 5 minutes or it's been 10 minutes and we only have this much left. Like everyone has a different way of working, and you can see who has empathy, who's smart, who's logical, who's emotional, and it's absolutely fantastic. And once they finish this, once the time is up, you ask them, okay, let's do this again. I'm going to ask you, now that you've worked together, to give the roles again. And it's a very tense moment usually, because if, for example, they elected someone commander and they realize that person didn't do well, they might have to change their minds and they have to say it in front of the other. And this is something you need to deal with. When you are in a dangerous environment, you need to be able to tell people when something is not good. Typically pilots, one of the reasons they don't really want pilots to fly together that are friends or know each other very well is that you always want them to be able to give feedback. You always want them to be able to say, look, today you're really not flying well. Today you're putting us all in danger. And if you're not able to say this because you think, oh, I'm going to be mean, then you shouldn't be that. Because those situations where you're for 2 weeks in a lava tube, those situations where you are 10,000 feet above in the air and you are flying 200 people, you are responsible. You are responsible and you are in a dangerous situation, and you need to make the right decision and the right communication. And this is why we do those kind of recruitments for mission. In this case, sadly, that mission in the end did not take place because we had some issues with the lava tube that we used in Iceland, but it has been then modified for Australia, and we're actually quite excited to see what's going on. This is a fantastic team, people that I really love and respect, and it's been an absolute pleasure to do that, and it has helped me a lot to keep that in mind for CHASM and to stay really active within the domain. Recently, we have spread CHASM to Asia, so we had several people contacting me over the years that wanted to work for CHASM. It was complicated because we have people in the US and we have lots of people in Europe, so already finding a time where all volunteers are available to discuss and etc. was complicated. But after so much interest, we decided to create a branch that is basically managed by one of my colleagues. And basically we just assist. We don't do as much as we do in Europe. We don't do workshops, etc. But we basically lend a hand to people who want to create analogues in the Philippines, in India, in China, and South Korea. So in India, we have ties with the Indian Air Force. In South Korea, we have ties with the Invention Week, and Philippines with the Philippine Space Agency. And this we started in January, and it's going quite well. And the latest baby, we kicked it off yesterday officially. Yeah, I'm showing you we're doing so many things with CHASM. It's going really big, and yes, it's not my main job, it's my side hustle, but it is most of my life, has been for the past 5 years. What we do now is that we realize that the purpose of CHASM is to make analog missions better funded, more accurate, have better experiments, and basically analog missions want to have space. We want to have more astronauts. We want to have people going to Mars, and we produce so much data. So what we thought was, why don't we talk to the European Space Agency? European Space Agency used to dislike analogues. They only believed in days. and now the opinion is sort of changing. And basically what we're trying to do now is to find a way to standardize experiments in several habitats so that we can use the results to be sent straight to ESA, and ESA can then use this information, this data, for the space exploration program. Yesterday we were in Darmstadt at ESOC, and we have the first meetup and discussion between analog heads about how we want to do this, because there's many things that need to be considered, from ethical committees, from data transfer in gathering, from what kind of experiments we should start with, which would we get the funding. And it's been really, really good. It's been a blast. And it's really exciting because it really moves us from CHASM was an idea in a shower, you know, and now it is an officially registered organization working with a space agency. And I'm absolutely incredibly proud of that. Really, it's been a lot of work. It's been hours and hours of work next to me doing my PhD and then working full time as a postdoc. And we really got really quite far. And another point where I'm really proud of is we made our conferences accessible to you all. So the first conference I ever organized, the ticket price was £25, sorry, British pounds, for food for both days, etc., and the organization. Which, if you've ever done a conference, you know that a conference can be about $1,000 a week or something like that. They're very, very expensive, and yet we managed to keep it quite below. So that was the first one. All our workshops, we tried to keep it below €100, even with traffic, transport, etc. And the last conference we did was last year. We did in Switzerland, EPFL, which was my first university. And you can see here, this is Andy. This is Bill, the speaker. Bill was working as a flight controller, actually, for NASA for many years. Now he's working at Blue Origin, and he's an analog astronaut who has worked on several missions. He did the Hera mission from NASA. He was in FMARS. He was in Houghton Mars project. Really lots of experience, and he came all the way for us. And Andy next to him is a sign language interpreter. With CHASM, we are trying to make missions accessible. We're trying to make space accessible. And what we want to do is we want to develop techniques, knowledge, and protocols that can be then applied to Earth. Space is only beautiful because we can also bring back the technology to better the lives of everyone. And this is one of them. There's no point making analog space mission accessible if we don't make our day-to-day accessible. So we translated the program in Braille for blind people, and then we had British Sign Language translators. The event was wheelchair accessible, and we also had everything recorded on YouTube. So if you are interested in learning more about analog missions, everything is on YouTube. All those talks, there were like, again, more than a dozen of analog missions. And I also give a talk on a class on analog space missions with different chapters like spacesuits and how to work on the logistics and habitats, etc., with also an overview of the different missions existing around the world. The course is now 2.5 years old, so things have evolved a little bit, but it shouldn't make a big difference to the skeleton of it. So if you're interested, you can have a look at that. But this is another thing that I'm incredibly proud of. It's to bring this accessibility. And we had parastronauts with us. We also had one of our speakers, she was 4 months pregnant. We also had a baby with us, and we even had a dog with us. So it was a very friendly conference that showed that, you know, space is for everyone, from any age, from any background. And this was really, really, really cool. It's another thing that I'm really proud of. So yeah, if you'd like to know a bit more about CHASM, if you'd like to stay in touch, I realize I haven't used Twitter in a while, but that was my coordinates for Twitter. If you do want to get in touch, let me know. Analog missions are really fantastic. Do have a look at our website, at the wiki. I really do recommend participating in an analog space mission. It really teaches you a lot about what you can do. And also, if you're a young grad student and you want to start something, like an organization, like a startup, go for it. many of times it was really hard to create CHASM. It was really hard to maintain it because I had so much work and I had to deal also with lots of family issues, and sometimes you just want to give up. But then you just talk to the right people and you realize that it's completely worth it and that we're actually making a difference. So thank you so much for giving me the opportunity to share what CHASM does and analog missions. I hope this was informative, and don't hesitate to ask any questions.
Thank you very much, Eleanor, for the outstanding and very informative and very impressive lecture that you have been done. It's a very inspiring talk because of, I think, with your age, and all the students will be definitely have many questions like how you just achieved those things and many of facts. Dear students, now we are just moving to our Q&A sessions. If you have any kind of questions related to today's discussions, make sure to write your hand symbol, and then one by one I can just call in your names. Okay, Lena, before we head into our student side, I have a couple of questions to you. Why you have been selected to this disciplines as a become an analog astronaut, and what's make you inspiring?
It's, I mean, the initial thing was simply that I wanted to be an astronaut, and that was how they got me. And then it was that when I did the first mission, I realized it's the best way to test how to be an astronaut, one of the best way, because you really recreate a lot of the conditions. And I mean, I'm not a huge people fan. I like having my own space. I have lots of friends, I have lots of colleagues, but I'm still someone who needs their space. You need to at some point, shut up and leave me alone, right? And I thought, if I want to be an astronaut, how am I going to deal with this? That I'm going to have people around me all the time. And it turns out that when I'm with the right kind of people, when we are all together, we learn how to work with each other. And I just fell in love with this. I fell in love with doing these things. When I do those missions, when there's nothing else going on but this in my head, like when you're doing a mission like this, you sometimes work 15, 18 hours a day. And I think the whole world could be burning around you and nothing matters. It's just you and the mission. There's nothing else. And this amount of focus, this amount of dedication that you can generate is incredibly appealing. And you will get that kind of feeling also when you do expeditions, when you're in the North Pole and stuff like that. But there, the extra bonus is that you actually produce data that is useful. You actually serve humanity. And this I really, really enjoy.
Yeah, that sounds much interesting, because I could remember like before 4 or 5 years ago, at the very first time while I was just trying to contact you was just trying to ride in a mini bicycle. I seen many of images. Then I was also just surprised, like she's doing many sports and other skills that he have. And what do you think, like doing something like extracurricular activities like sports and some hikings? And I noticed that a lot of activities from you, like how important those things while we are just considering to become analog astronaut, same as like we are like following that academic platform. Of course, that's true. But what do you think, like it's a 50-50, or what is your experience?
Yeah, I think that extracurricular activities are extremely important. I'm not a good student. For like when I was very young, my grades were very good, but as soon as I was a teenager, no. and for me, it was like, okay, I'm never gonna achieve high stuff for the simple reason that I'm not the best student. But I never liked when people told me what I could not do. The thing is, if I want to do something, I'm gonna do it. Which meant that I started teaching robotics when I was 15, because I was taking a robotic class and then they needed someone to help. So I started doing that. I've been doing sports since I was a kid. I bought my own bike when I was 18. My dad didn't want to give me money for it because it's dangerous, so I used my salary to go as a robotics assistant to buy my own bike, and I started cycling everywhere with a single speed. When, if you know Switzerland, it's like this, so single speed is actually really hardcore, but he still was determined. And in dangerous sports, I've done Ironmans, and I also play handball. And those sports, they need a lot of resilience. They need a lot of mental toughness, which are required for astronauts and analog astronauts. And Like, I really see a big difference between people who potentially have never had to face something difficult in their lives and also do not have that kind of activity in their lives. They don't know how to push past the pain. They don't know how to be, at some point you don't become confident, in the sense that you don't think necessarily that you can do it. You just think that you will try whatever it takes. And that's the big difference. It's not thinking I'm the best, I can do anything. No, it's that I will try no matter what. I will try no matter what, because the odds are really low. And this is how I got my PhD, my master's in Cambridge. It's like I had a lot of my CV. I had done lots of them because I went and I annoyed people, like, to get my internship at Pilatus Aircraft. I went to every space in aeronautics workshop with my CV, and I was like, take me. And then it took me. And then for Cambridge, I signed my CV and my motivation letter and my grades, knowing that my grades were not good enough. And that's how I got a fully funded master's and PhD. I did that as a joke, but because I tried, I got in. Because I went to Cambridge, I got my postdoc. And your whole life, it will be like this. It will be about how often do you try and how much do you want this to happen. If you want this to happen, and maybe it's not going to happen in a straight line. Life is never a straight line. And thank God it's not a straight line. It makes it way more interesting and difficult. But it's because of this trying and because of this resilience that probably I developed with endurance sports. But yeah, and from a just physical standpoint, really just your fitness level, analog missions, they're not necessarily very physically difficult. It's more, it can be uncomfortable. Specifically when you do EVAs and you're in a spacesuit, it's very, very warm. It can be very heavy. So if you have any medical issues, you anyway cannot do a mission. So you will have some medical criteria, but it doesn't mean that you need to be a champion. You need to be good at many things, but you don't need to be excellent at anything. We don't want people who like train 60 hours per week, because when are they going to be training 60 hours per week, you know? So just no extremes, but just a base level of fitness. Yeah.
Thank you, Eleanor. That's very inspiring, and now I can understand that why many of analog missions and their organizers giving you some commander post, and you have some good leadership skills, and it's highly important. And I think like young students can learn a lot of things from you, dear students. I can see some of students have been just already raising their hands, so I'm heading to the little one. Sorry, go ahead, open your microphone and asking your question. I hope like you are getting fine now.
Savin, did you want to ask your question? Or you can also write in the chat if you prefer. There you go.
I just want to know, what are the future projects that you have in mind?
Okay. For CHASM, so right now, CHASM, we have all those projects already. One of the things we're doing is we're going to modify a habitat in Brazil to make it accessible for an astronaut in a wheelchair. We're working with this guy also for the astronaut that is deaf. So this is two things we're doing with her astronauts. We're working with ESA, and we're going to do more and more experiments until all of them are standardized. So these are things that we do. Personally, I'm finishing my pilot license, so I'm flying planes, and I'm trying to have my exam next month because I want to learn how to fly and to teach others how to fly. So the goal is that I become a flight instructor, so I could teach others how to fly. So these are the some of the projects we have. And I also have plans to do, as I mentioned before, analog missions and expeditions. They're not too far off. And I want to go to Antarctica for 2 months next year to do an expedition.
Thank you for answering that question I had. And that is a lot of nice projects you have in mind.
Yes, I'm super excited.
Thank you for the compliment, dear Zarin. And next I am moving to the Danitma. Yes, Danitma, go ahead, asking your question.
I don't have any questions, but I found this outside.
Oh, let's check.
What color is the rock?
What is it? It's a rock?
Crystal-like rock.
Ah, crystallized rock. We just found a
Nice.
crystallized rock.
It's not oxygen, is it?
Yes, Eleanor, but in Sri Lanka there is no obsidians. So it's
Okay.
almost like
I'm
it's almost like that. Yes, I know that why you are just telling it there are many of things in Switzerland. The shape.
you know, when I was what, 5-6 years old, I loved rocks like crazy. I loved them.
Yeah.
So I would get any rock I could find. I still have a rock collection actually, and I thought about becoming a geologist, and then in the end I was like, nah, I prefer engineering, but materials science is still very close to that in a sense. So I never really left my love for
Yeah,
rocks.
definitely.
Keep bringing rocks, because sometimes also when you cut them open, you can find some gems. And I mean, Aravinda is the best to know about that, right? That you find fantastic things and discoveries. So keep picking the rocks. Just bring it back, because your mom's going to be tired of, carrying the rocks for you at some point. Thank you for showing us.
Yeah, thank you, Danitma. Then I'm moving to the Natupa. Natupa, go ahead, asking your question.
Can you explain the process of observing celestial bodies using analog methods?
It really depends where your analog mission will be. Most of the times we're within a habitat, so we can be, if we're underground, for example. We did once an experiment where we tried to collect solar particles. So we just had a count within the thing. We're trying to see, is there anything that actually goes through the building? But most of the time we do not do planetary body observation doing analogs, because it doesn't really cover the scope of what you would be doing on the Moon and Mars. Like, for example, if you look at Buzz Aldrin and Neil Armstrong, they did do some solar array experiment. That was actually the first Swiss experiment on the Moon, but themselves, they're not with a telescope looking at other planets. This actual telescopes like Cheops and James Webb Space Telescope, etc., they're way better than humans for doing that. So I wouldn't be able to point you out any other experiments that would really make sense for us to do.
Okay, I got one more question.
Sure.
Does analog astronomy help in studying celestial events like eclipses and meteor showers?
Not really. Like analog astronomy, yes. Analog missions, no, because we're really focused on the logistics of being and these things. You could still try and find experiments that could make sense. Typically, when we have missions in the Arctic or Antarctica, and we don't have any night pollution because there's no human construction except us, then it's really, really good for some observation. But it's, again, not something that would necessarily be done in real life on the Moon and Mars. At least I wouldn't think so. Maybe Aravinda, you think yes. I wouldn't think it would be a priority, to be honest.
Okay. Can you describe some historical developments in analog astronomy?
Some historical level what?
Some historical developments.
For analog astronauts?
Yeah.
Historical developments. I mean, that you can have a look for. It's really fantastic. When we started with the first Gemini Apollo mission, so the first human space flight, we had to test lots of components. This is how analog missions were born. But usually they wouldn't do the full mission. They would just do some tests of this and that. So you have pictures of astronauts wearing a spacesuit and a cowboy hat, because they were in Arizona and it was really warm, so they had to protect themselves from the sunshine. So they look crazy. And then they also did a training, like, when astronauts come back to Earth, they might land in Siberia or they might land on the water, so they have to train for that. And there's a photo shoot of there's Neil Armstrong, and I can't remember the other astronauts that were with them, but they did a survival training like we do for analog missions. And they used the parachutes of the capsule to basically create clothing and a hammock and a tent. And there's a picture of Neil Armstrong. He looks like a Shaolin monk. Like, he looks so cool. So you can see, I think you can find it on historical images. You just put analog mission or extreme environment training for astronauts in Apollo era. and you will find some amazing things. So these were some like milestones, is the birth of analog missions. And then there's just many milestones, like the first parastronaut, the first 500-day mission, the first international crew. It really depends how you want to view it. So it's not as big as space missions themselves, but they still have lots of moments to celebrate.
Thank you, ma'am.
Then I think Asindu, if that's great.
Yeah, I think like it's a series of the questions. What I noticed, like we are usually doing some analog missions with the celestial constellations and the observations. But I think we can just do some analog simulations with some meteorites and other things that which is fallen into the planet Earth. So, but not for the observations part. It's not that much practically sense, as you said. And it's a very good questions, Natup. And then I am moving to the Hasindu. Go ahead.
I have two questions about the lava tubes. First question is, how could lava tubes on the moon help us to prepare for similar structure on Mars?
How would landers on the moon help us with similar structures on Mars? You were talking mainly for lava tubes, is that correct?
This one.
Yeah. Okay, so basically the concept will be the same. The geology will change obviously a bit. So what we're trying to look at is for example, the physical integrity of these lava tubes. So if you imagine you make your lava tube, once it's made of concrete, and other ones maybe made of sand, and they're not necessarily going to be, as stiff. Now, I don't know about the differences in geology. I just know that there will be some differences, and per lava tube it will change. So imagine you are right now in your tube, for example. I'm in there, and I'm going to put a habitat there, and maybe there's an earthquake or there's a mass quake. Maybe some of them they're going to be quite resistant, and maybe some not, and they might crumple or damage the habitat. So what I think the moon mission will be important to have is to learn, first thing, are we able to put a habitat, for example, an inflatable habitat, to build a habitat, and how quickly? Like, is it too much work, or is it worth it to protect us from radiation? The second is, can we anticipate moonquakes and Marsquakes? So seismic activity, I mean, we don't need to send humans on Mars to go and do this monitoring. We can already send some things over there and see what already happens, how predictable they are or not. And this way it tells you, okay, is this possible? And do geological measurements. So the lessons learned of moon missions will definitely help with Mars mission, but there will be some differences for sure. And we need to do some science before we can do that. Probably we will still have some surprises once we get to Mars. I mean, usually life is never easy that you know everything, even with all the tests possible. It's a very space-specific thing too, that we always have new surprises. But you can try and get as much data as possible.
Second question is, how might studying these lava tubes improve our understanding of planetary geology?
I'm not sure I get your question. Can you say that again?
How might studying these lava tubes improve our understanding of planetary geology?
You need a geologist that can answer that question. I'm not a geologist,
Yeah.
so
I think
maybe you can answer.
Yeah, I think it's completely deviate from the today's topic, but anyway, it's a good questions, and because of Dr. Eleonore is a professionally analog astronaut, she's studying about the materials, and what you're asking is completely different subjects and the planetary geology, but in here still we didn't talk about. But it's very important, even that previous questions, even Dr. Eleonore already informed, like studying the moon's lava tubes are highly important to get understanding about the Mars because of its temperature and the properties and the minerals which content on on planetary bodies. It's depend on their self, because of we can't say like how Mars become a crystallized some minerals and other things, and it's completely different what happens on the moon. So because of these are completely different planetary bodies, And I think like in the future we can just furthermore discuss, and everything it's highly important because it has some common phenomena like metamorphic, igneous and sedimentary rock formations, but the environment, air gases and other mineral properties are completely different.
Thank you, Madam and sir.
Okay. Is it thank you, Madam and sir? Credit should be goes to the Eleanor. Then I'm going to wind up this today's session. It's a very important day for every student because of I hope like Dr. Eleonore Poli is one of the youngest analog astronaut that ever we have. She is supporting I think like since last 5 years for the many of Sri Lankan Indians and a lot of students. She become a very talented and very inspiring one. Year by year, that's a very good symbol for you and us, even for the Sri Lankan students. Dear Eleanor, thank you very much for your devotions, time and everything. I know it's a very busy and a scheduling time for these days for you, but you accepted our invitation as usual. And I hope like in the future, we have a lot of collaborations and we can just keep continuing the journey with the Asians and other continentals as we already discussed. Again, thank you very much for your time and see you soon. Dear students, good night and good morning and have a nice day. We will see you at the next week. Okay, bye.
Bye.
Have a
Amazing. Stay safe, work well, and keep loving science.